This video is about the physics concept of pressure. Imagine you had two books sitting on a table as shown in this diagram, and imagine that the books weighed the same amount. The upright red book has the same weight as the blue book, but it exerts a greater pressure against the table surface compared to the blue book. The amount of force per unit area is called pressure. So pressure is the amount of force that is applied to a particular area. It's force divided by area. This formula actually only works if you are talking about a perpendicular application of force, but for our purposes, this is the only formula that we are going to look at. We can symbolize it with letters. Let's capitalize everything and just make it P equals F over A, where P is the pressure, A is the area over which the force, F, is applied. Now in the metric system, force is measured in newtons, area is measured in meters squared or square meters, so the pressure units would be newtons per square meter. That has been given its own name as a complex unit. Sometimes we rename them and simplify. It's been given the name of pascal. The pascal was named after a physicist mathematician named Pascal. It's abbreviated capital PA since it was named after a person. So 1 Newton per square meter or per meter squared is equal to 1 Pascal. So here's our formula again, and like any 3 variable equation, we can put this into a magic equation triangle. Since the force is on top of the right side, let's put that in our top spot. That leaves the 2 bottom spots for the other 2 variables. It doesn't matter which order you put them in, we'll just say P and A, like that. Now that we have it in a magic equation triangle, we can derive any formula for an unknown variable given the other 2. So for example, if we wanted to know force, then we'd pull that out of our box and say F equals, and what's left is P beside A. That means pressure times area. If we wanted to know area, we'd pull that out and say area equals, and we see that it's force over pressure, or F over P. So think about this question. If you're standing on 1 foot instead of 2, the pressure you exert on the ground is half, the same, twice, or quadruple. Think about it. I hope you picked C, twice. You weigh the same amount, that's your force against the ground, but you've cut your area in half. If you do the math, that means you exert more pressure against the ground when you stand on 1 foot. In fact, anytime area goes down, if F stays the same, P has to go up. That's simple mathematics. If your denominator in a fraction gets smaller, then the result must get larger. So the smaller the area supporting a given force, the greater the pressure on that surface. Let's do a quick check of your understanding. Which of these is the definition of pressure? I hope you picked D. It's force per unit area of application. What was the metric unit of pressure? Since it's force divided by area, it's newtons per square meter, which has been given a simplified name of the Pascal. Imagine you're on a pond covered in ice. The ice begins to crack. If you lie down on the ice and begin to crawl, this will you weigh the same amount, but you've increased your area in this case. If the denominator gets larger, then the result gets smaller. So the pressure on the ice decreases. The force doesn't change. The force in this case is your weight. A book weighing 10 newtons is placed flat on the table. If the book has a cover area of 0.05 square meters, what is the pressure on the tabletop? All you have to do is apply the pressure formula. Let's identify what we know. We see that force equals 10 newtons, area is 0.05 square meters, pressure equals force over area, so that equals 10 newtons over 0.05 square meters. You need to pull your calculator out to do the math. You'll find that to be 200 Newton per meter squared, which, if you'll recall, the Newton per meter squared can also be called a pascal. So you should have picked answer D. Remember, weight is a force. There are other types of forces that can also cause pressure, but everything that has a weight can apply a pressure. Everything that can exert a force can apply a pressure. This includes fluids like water and air. In fact, if you ever listen to a weather forecast, you may hear them mention air pressure. Air pressure is the weight of the air pressing against a given area. That could be against the ground, against the roof of your house, or against your skin. Air pressure can change due to different weather conditions, and that's why they monitor air pressure. When it's going up, usually good weather is coming. If the air pressure is going down, then rain or some form of precipitation may be about to occur. Let me leave you one last think question here. I want to know how much my car weighs, but I do not have a scale to put it on. Can I do it some other way? Well, if you know anything about cars, you know that there is pressure in the tires. We can actually make use of the pressure formula. The F in the pressure formula will be the weight of the car, and what we want to do is solve for that weight. So you can actually weigh your car by measuring the amount of area the tires are in contact with the ground. That's what this fellow is doing. He's put a sheet of paper under the tire, and you can draw a little line around it and then move your car and measure that area. And then also measure the pressure in each tire, which is very easy to do with a simple little gauge. If you add up the pressure times area for each tire, you will get the weight of the car. It may not be accurate to an exact pound, but still it gives you a pretty good estimate. Now, I don't know why you would ever want to do that, but I just wanted to show you there's always more than one way to solve a problem. So let's remember that pressure equals force divided by area.